So this one, we look at linear equations and functions. Remember, the same thing, y equals the difference between like regular linear equations and functions. It's just the first term. Y and f of x mean the same thing. They're the same thing. So equations and functions, that's the only difference, is just the way they look. We have two properties that we have to talk about, or principles. The addition principle the addition principle says this. It's pretty straightforward. If A equals B, and we add a number C to A, and because of equality, we'll do the same thing, then they're equal. Sorry. If 3 equals 3, and if we add 2 to the left side, they're still equal. That's what the addition principle tells us. Whatever you add to the left side, you have to add to the right side. The multiplication principle of equality, I should say. These are equality principles. If A equals B, and if I multiply a number to A, and I have to do the same thing to B, they're still going to be equal. So if 3 equals 3, and I multiply the left side by 4, I got to multiply the right side by 4. I get the same thing. Yeah, these seem pretty straightforward, but here's what's really going to happen. If x equals 3, and if I add 2 here, then I have to add 2 here. So x plus 2 is equal to 5. Means the same thing. If x equals 3, and I multiply 4 to x, then I have to multiply 4 to 3. So 4x is equal to 12. That's what it tells us. Whatever I do to one side, I got to do to the other side. The golden rule type stuff. All right, example 1. Three-fourths x minus 1 is equal to 7/5. We just did a question like this. Remember what I said? Whenever you have fractions and an equal sign, what are my procedures? First off, find the LCD. What's the LCD we have here? Nope. What's the smallest number that both of these fit into? 5 doesn't fit into 1. If you have a hard time figuring it out, then just multiply them. So the LCD is going to be 20. Instead of wasting your time, it's going to wash out at the end. Just multiply all the denominators. It'll wash out at the end. But yeah, in reality, though, that's the smallest one for this one anyway. So what do we do with the LCD? We multiply the LCD to each term. So we have 20 times 3/4x, 20 times 1, 20 times 7/5. Remember, each of these are terms. A term is anything separated by a plus or minus. So I just multiply each term by 20. What's the third step? Reduce. Whenever you multiply by fractions, never multiply first. Always cancel, make them smaller, then multiply. So can anything reduce here? The answer should be yes, because that's how we got our LCD. 4 goes into 20 5 times. 5 goes into 20 4 times. That's what we have now. These two are exactly the same equation. It's just the bottom one looks a lot easier to deal with now, since we got rid of the fractions. The fourth step is multiply to get rid of the parentheses. 5 times 3 is 15x. 20 times 1 is 20. 4 times 7 is 28. Now solve for the variable. Add 20 to both sides. And then divide by 15. Everybody should know this process already. I mean, it's how to solve for a variable, move things around. Can anything simplify here? 3. 3 goes into 15 5 times. 3 goes into 48. 3 goes into 4 once with 1 left over. 3 goes into 18 6 times. So there's your answer. That's what x equals. Example 2. 2 times 5 minus 3x equals 8 minus 3 times x plus 2. So how do we solve this one? What's the first thing you got to do? There aren't any fractions. That's good. Get rid of the parentheses. Yeah. Since we have x's inside there, we have to get rid of the parentheses. So distribute. 2 times 5 is 10. Positive times negative is negative. 2 times 3 is 6x. Negative times positive is negative. 3 times x is 3x. Negative times positive is negative. 3 times 2 is 6. Whenever you get rid of parentheses, the first thing you should always do is combine like terms. There's nothing on this side. We have 8 minus 6 equals 2. Now, this is another set of the rules I'm trying to teach y'all. We have x's on both sides. Which one do we move? What's that? This one? No. Well, yeah, you can, but again, if you move this one, you're still gonna have a negative in front of the x. If you have x's on both sides, always move the smaller x to the larger x. Negative 6x versus negative 3x. Which one's smaller? Negative 6. So let's get rid of the 6. So we add 6x to both sides. Six minus 3 is going to be positive 3x. So now we have a positive in front of our x. We don't have to worry about signs anymore. If we did it the other way, we'd have a negative 3x, which we have to worry about the negative sign at the end. Again, it wouldn't matter. It's just that try never to deal with negative numbers. Negatives hurt. Solve for x. So subtract 2. 8 equals 3x. Divided by 3. So x equals 8 over 3. Note, I forgot to tell you, there's always, whenever you have an equation like this, when you're solving for x, always check your answers. In other words, what we should do is, in place of x, put it inside here, put it inside here, and see if both sides are equal. So always, 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 always check your answers. Example number 3. Negative 24x plus 7 equals 17 minus 24x. What do you do first? We have x's on both sides. They're the same size, so it doesn't matter. So we add 24x to both sides. So the x's cancel, the x. Now, if you get in this scenario, this situation, all the x's are gone, do these equal? No. So there's no solution. There's no value of x that would make that work. If all the x's are gone and the numbers aren't equal, not going to happen. No solution. Example 4. 3 minus 1 over 3x equals negative 1 over 3x plus 3. What do we do first? Yes, we have fractions and equal sign. So the LCD is 3. Multiply each term. Is this a term? That's a term. That's a term. That's a term. Reduce. So 3 times 3 minus 1x equals minus 1x. 3 times 3. Multiply. 3 times 3 is 9. Minus x plus 9. Add x's to both sides. Now, what that means is we have an infinite number of solutions. Any value x you put in there will work. Make sense? So those the last two are the very tricky ones. If all the x's are gone, see what you have left. If they're not the same, no solutions. If they're the same, infinite solutions. Okay, now the part that you all have been waiting for eagerly. Well, it's 11 o'clock now, isn't it? We have to do word problems. That's what we're gonna do next, are word problems. But since it is 11 o'clock, class is over. We'll pick up from here next time.